Right, this evening I want to have a look at the Hacker chassis again, because it also looks to me now like there's not enough B plus on the supply. The rail looks like it should be around 250 volts on the anode of the output valves. I'm actually only getting about 170, so I need to investigate that, and that's the plan for this evening. And it actually was the plan for last night, but unfortunately things didn't go quite how I planned. I came down to the workshop yesterday evening after work, and put the power on the workshop to warm it up and put the heater on. Something I've done for the last 3 or 4 years in this workshop. Put the same heater, turned it on, went indoors, had a cup of tea. And I noticed when I was indoors that the light just flickered, and I didn't think anything of it, to be honest with you. Anyway, I drank my tea and came out to the workshop, and I could hear a beeping sound, and I thought, that's strange, what's that? And then I thought, no, it sounds like the carbon monoxide alarm's going off. Anyway, I walked down the steps to the workshop, and there was no light at all. Opened up the workshop and was greeted with a black wall of smoke. Acrid plastic, burning smoke plastic. So panicked and sort of opened the door. The power had been obviously tripped out. That's what the lights flashing in the house were. Got the door open, managed to get to the other side of the workshop, pulled in my breath and opened the window, get some air through. It was quite a blowy evening last night, which was good, so it cleared fairly quickly, and I could see on the floor where the fire was. All was left was a metal aluminium fan and a load of flames. It was all on fire still. So I've got a fire extinguisher, put that out pretty quickly, and unfortunately it's a powdered fire extinguisher, so I've got dust absolutely everywhere. So I spent the rest of the evening clearing up soot and smoke damage from the fire I had in the workshop. Something that really knocked me back, I must admit, you know, and there's still dust everywhere now. I've got to come in here with an airline, try and blow some of the dust out. But so basically I've just recovered from quite a major fire, and it's surprising really. I sort of like a word of warning. I've trusted that fire. I've used that fire loads and loads of times. It's one of those convector fans, and it has been on in the workshop through the winter for hours on end and never caused a problem. And the moment you walk away from it, the bloody thing catches fire. Thank God it wasn't, you know, thank God the workshop isn't connected to the side of the house, because if that had been the case, I would have ended up possibly doing a lot more damage and putting a lot of people's lives at risk. So I'm going to try and forget about that rather unpleasant evening last night, and let's get on with this radio. So yeah, we've got low B plus here. We've got about 170 volts. So I need to get this back to sort of 250 volts. So the first thing to do is check this capacitor here that I haven't changed, which is C8. And I think probably what I'll do is I'll just disconnect it for the time being, and then see when our B plus comes up. So it could be this capacitor pulling it all down, though I don't think it probably is, because here's the rectifier, and the voltage is fairly low straight on the rectifier pin, so it suggests to me that this Selenium rectifier is become lossy. You know, it's got a lot of full voltage drop. So the other option to do is I'm going to fit a silicon rectifier in there, and possibly have to add a dropper resistor to get this down to around 250 volts. That would also explain why the Magic Eye is so dim. Obviously the tube isn't as low emission as I thought, so I'm going to have a go at that. So I think we'll have a look this evening, just check our voltage again, double check our voltage. I also want to see that if the voltage starts to collapse as the valves start to conduct. So I want to see if the initial voltage is high, you know, if it can manage 250 volts off load, and then as the voltage will drop down as the valves start to conduct and draw current from the high tension. Now, it could be this capacitor's leaking. This is the only one that hasn't been changed. I've replaced this one. That made no difference. So let's get on with that. So what I need really is a meter. Unfortunately that's right by the camera. I suppose I could use the HP. I'm just going to have to move the camera a second. Now if it is the Selenium rectifier, I think I've actually got a spare Selenium rectifier somewhere. I've had it since, you know, well, I've had it for absolutely ages. I think it's probably one I collected when I was a kid, and it's been kicking around in my box of junk for sort of 25 to 30 years. No idea what it's like, but it's a good chance that it might be better than the one that's in here now. I certainly seem to remember seeing one. I've just got to dig out, find where it is and dig it out. Or the other option is, this is the Selenium rectifier here, and this is the thing I want to check the voltage on straight up first thing. So there's our Selenium. Now they're notoriously high voltage drop on them anyway. Here's a positive terminal, here's a negative, and this is the AC side in. So let's switch it on. Where are we? Let's get on to volts first, because what I'm going to do is just see what it comes up to straight away. And there's another place I haven't dusted. You see there's absolute dust everywhere. It's an absolute nightmare. I'll come in here with the airline on at the weekend and try and blow it all out, get it all off the surfaces and things, because there's so many bits and pieces in here. Okay, right, so this is the positive output of the Selenium rectifier. Initial switch on. I've got 260 volts, so 270. Okay, that's alright, 270 volts. Let's let that wait for that to start to drop now. 260, 240, starting to draw current from the valves. 220, dropping back too far now, 200. So it is possible you've got actually a leaky grid valve in one of the outputs. Now it's dropped to 190, see that the spec's 250, which does suggest that the amount of current, either the current's excessive or the rectifier is very weak. So let's turn that off a second. What I might do is obviously drawing more current as the plates start to conduct. Now that could be these output valves. So let's pull these output valves out, these ECL 86s, and see if that improves. I expect to see some improvement, but let's see if it makes a huge difference to the amount of current being drawn. So pull that one out, and that one out, and let's repower it again. Why have we got no voltage at all now? Should have supply without the valves in it. Oh, lights are on. Oh, earth lead's come disconnected, that's right. Okay, it's 225, 228. So it looks like it's possible that the output valves are drawing too much current. Now there's a biasing network on these valves. It's fairly straightforward. There's not a lot really that can go wrong, so it might be worth checking a couple of those resistors first. Now the other thing is that if it's got a leaky grid capacitor, where are we on the grids here? You can't really see here. I mean, all these capacitors have been replaced. I'll check the polarity on them, but the caps have all been replaced. So I think the next thing to do is to get another rectifier in there and just see what that does. See if it improves things. Just checking the voltage again. If you've got 225, it's still low. You know, it should be 250 volts. So I think it's just basically that rectifier's knackered, and also it was getting very warm. I didn't did notice that, and it's probably had quite a hard time actually, because if you remember the original electrolytic that was in there, it actually popped its core, so if the capacitor gone leaky, it probably overloaded the rectifier anyway. So I think the thing to do is I'll have to see if I can find a silicon replacement. I think I don't really want to put another Selenium rectifier back in there, but let's pop the other valves back in again. Now, I thought the sound was slightly distorted when I was running the radio, and I sort of questioned the alignments as well, because the alignment's suggesting you excuse me, that you sweep it with quite a wide frequency, and I put a question to the some of the members on the hacker forum, and they're saying, well, really, quite honestly, with the modern deviation of only 75 kilohertz, they just do a traditional sweep on it. So I think that's probably what I'll do, because that will actually give me the benefit of more gain if you sort of peak the transformers higher and don't go for the width so much. We should be able to get a slightly better gain on the amplifier, on the IF amplifier. So I think that's what I'll do, and I can see if I can find a another rectifier. We'll do that, but just out of interest, see how much brighter it makes the magic eye if I disconnect the tubes. You see it's fairly bright at the moment. You can see it's dimming off a bit. Let's take one of the valves out. I have to admit, there's no noticeable difference. Let's try the other valve. It's just one valve's pulling it down. Jumped briefly. No, not really. I mean, I think basically there's a bit of a dodgy valve socket, but okay. So what I'll do is I'll dig out another rectifier. We'll put that in, and we'll go from there. Anyway, thanks for watching. Okay, I found a rectifier that's suitable. Voltage is about right, about 400 volts DC. So we're going to fit that. I've taken the old Selenium off. Doesn't smell of fish yet, which is a good sign. Can't see anything obviously wrong with it, but then again, I don't think you can really tell with those things. So we'll fit this back into the radio. I'm not going to tighten it for a minute because I need to get to the connections. So we've got the two AC line wires here. There's one AC one, so actually, yeah, I'll tighten it there and there because there's the two AC points here. I'll show you those in a minute. Let me just tighten the rectifier back up. So that's the first AC wire, I'll go there. What I'm going to do is just give the connection a bit of a scrub, because these devices have been kicking around in the workshop for so long, they're probably pretty gunged up. Now this is a nylon brush that you can buy, and it's just lots of fine nylon bristles on it. And they're really good for cleaning up old contacts. And you can see, I don't think you probably can't see, but these contacts coming up like new. So hopefully that will take quite easy to that solder joint. So first AC supply, I'm going to cut this one down a bit so it doesn't look untidy. I don't know if you can hear that noise in the background. They're redoing the road outside, or up on the main high street, and I've got the door open to get some air in here still, because it's still a bit whiffy in here from burning plastic. So that's what the noise is, if you can hear it. Okay, they're the two AC supplies, and the negative, oh, it looks like the negative lead will reach. That's a bonus. So I'll connect the negative lead up, and that's the 0 volt line that just goes straight to chassis. There's our 0 volt connection. Just needs soldering. So we got the B plus. I don't think either of those will reach. I'm going to have to rewire those with a new piece of wire. So let's remove. Okay. I don't think that will reach. I'm not doing a stretch. I could actually turn the diode around and then it would probably reach the rectifier around slightly. I really want to replace the leads if I've got the leads long enough. Should work. Just about reach. Okay. Tight, but it should reach. I think I might have to extend that lead actually, do a job decently. I'm going to have to extend the other red wire anyway, so I think the best thing to do is find some more wire. Get some wire. So this is just the connection to the reservoir capacitor. That. Some solder braid somewhere. Everything's filthy in here, it's horrible, everything's bloody dirty. This is the positive lead to the electrolytic. Okay, that's the other capacitor. Let's solder the wires up and see what we get. This is the AC in. Another AC in. The negative of the bridge. And the positive. Good. Right. Let's see what we get now. B plus. I'm so used to calling it B plus. That's what the Americans call it, and we call it sort of like the HT line. B plus, I think, originally meant for battery positive, but obviously it's not a battery supply. But I'm so used to saying B plus, I don't think it really makes any difference here nor there. Okay, let's try this. Let's hope it's got rid of the right way. Don't want any more excitement in the workshop for a while. Got 320 there. Bit high. Let it settle down. It's still 320. Maybe 30, but that magic eye's gleaming. Okay, we need to back this off a bit. So it's got loads of B plus now. So let's just have a look, see how bright that magic eye is. I don't want to run it for too long, that might damage the valves, but in theory, it should have a nice bright magic eye. Yep, well, that's better. Okay, so we've got probably we've got too much B plus now. So what we'll have to do, it's going to need realigning, I should think, after that. So we'll have to fit a series resistor to try and drop the supply back a bit. I'm wondering if I should do it in the negative line. It would be easier to do it in the negative line, just fit a power resistor in there. I think a bit of a guesstimation of what to put in there. I would go, depends on the current going through it, I suppose. I think I'll probably go for something like a, let's have a go. I think we might see a bit of smoke here, but let's see what we've got. I reckon, let's find something nice and chunky that will, it's going to get hot, but it should be 390 ohms. I think that's probably too high. Let's go for it. Let's try these. Let's try 220 in series, see what that does. ATR. Just patch it in, and then we'll just see what the supply line comes down to. And then we can just measure the current later on, and then we'll just work out what power resistor I need. If you know the current and you know the voltage, you can actually work out the value resistor. So, maths has never been my strong point, and remembering all the equations and things was never my strong point either. I've always been one to sort of tack it on and try it and see if it works. I'm not an engineer. I just like to tinker around, really. But I get by. Okay, let's try that. I'll probably see a bit of smoke. Don't be alarmed. You ain't seen smoke like I've seen smoke. Right, okay. Switch this on and try. So we should see a reduced B plus voltage. We are also running on the isolation transformer, so we will get a reduced supply. Well, I don't know what bloody resistor that is, but what am I doing? Oh, of course, because I'm on the negative round. Sorry, I haven't got enough much voltage drop across here, but it looks at 260. Oh, okay, 260. That's good. Resistor's smoking. You see the resistor smoking there? That's alright though. You know roughly what value we want. 260 is good. Magic Eyes, much brighter than it was. It looks like it's stabilising. I've got a speaker on there at the moment. So we've got 18 volts across a, we put a 220 ohm in, so it's dissipating quite a few watts. But that's alright. Let me just, yeah, got 18 volts across there. A B plus is now 260 volts. Quite happy with that. So what I need really is something like a 220 or maybe a 240. I don't know, like a couple of watt resistor, 5 watt resistor. But you might find that's in specification. I'll do a quick calculation of the. Oh, I've got a calculator here. My girlfriend's borrowed it for the couple of nights. So, but anyway, it looks like it's working. We've got the B plus voltage down. All I need to do is really connect that resistor to that binding post there, and have a look, see how hot that resistor gets. But yeah, thanks for watching. What I might also do is, because I've got some high values, so just couple in parallel will sort that problem out. Yeah, anyway, thanks for watching, and then what I'll do is I'll get it back together again, and we'll do another alignment on it, and hopefully it will work a little bit better.